Dear colleagues, I would like to make a presentation on the topic Design and Implementation of Advanced Web-Based Dictionary System for Ukrainian and German languages. The content of my report presented on this slide. There are a large variety of IT solutions for electronic dictionary system. One special and not important challenge is how to provide more intelligent and sophisticated function of this software solution, in particular taking into account the phenomena of lexical parallels in different languages. The main task of this research presented here. Some of the linguistic terms presented on this slide. Web-based dictionaries are used intensively, and in order to implement all solutions with advanced functionality and higher quality, the existing ones were investigated to define common functionalities, some advantages and shortcomings. Here the main interface of Ukrainian academical dictionary website is shown, and some other examples shown on the next slide. Based on performance investigation, we can make a conclusion about the set of typical components and services menu bar that contains some control for user authentication and navigation, input fields to customizing search for dictionary articles, and other service components, controls for dictionary selection, alphabet to search articles by first letter, and so on. It is necessary to define the appropriate data model that will be processed by software solution before start to design graphical user interface and implement its functionality. The dictionary article structure with linguistic parallels was analyzed to build a target data model, and this result is provided as UML class diagram. This data model contains the next entities: word article, word and morphology, word definition, equivalent word definition. Word article entity represents the whole dictionary article and contains two fields: first language word, list of first language words, and field other language words. Information about word or words when similar spelled synonyms are provided, and definition represented by word entity. Class word contains two fields: word and morphologies, represent list of words and its morphology, parts, and field definition, list of definition for current word. A usage scenario for dictionary entry with lexical parallels in use case notation was elaborated and shown here. It has all common functionality to other dictionaries and some specific representation and advanced administration access. As there were requirements to consider system for future extension and decouple different pieces of functionality from each other, it was decided to use microservice architecture to meet these requirements. The process system architecture is shown as UML component diagram. It was decided to use document-oriented model with MongoDB, since all operation related to article occurs with a whole article object. The target UI design presented on this slide. There is a main menu, navigation bar, and list with articles. There are different ways to evaluate designed interface. The GOMS model allows to evaluate UI using time intervals for specific simple actions that have been determined experimentally. GOMS has the next list of actions with its time interval: key pressing, cursor moving to a specific position, moving hand from mouse to keyboard, or vice versa, mental decision of next action, waiting response from the system. However, such action could be extended with respect to the specific feature of the target user interface. In our case, we are dealing with search results that could contain quite big amount of dictionary articles ordered alphabetically. Scrolling time that is required for navigation to the target element, focusing time that is required to catch necessary information. Using GOMS rules, we will receive the next navigation sequence: H, P, P, K, and so on, where the H letter means taking computer mouse, P letter means moving cursor, and so on. In the mapping to each letter, to its time interval, we will get about 12 seconds that take the whole result searching. Then we have applied a GOMS Plus model to our target UI and got the following sequence: 8K, 6P, 1H, 1M, 1S, 1F, and applying time intervals, we get about 10 seconds total time. So the more effective results were achieved setting focus on input fields after page is uploaded, which allows to omit mouse movement to select the input fields. Web interface evaluation results using GOMS after enhancement shown on this slide. It would be seen that navigation improvements done in the target UI are about 12%. So the main results are: it was performed overview of existing solution, was proposed own framework to develop electronic dictionary. It was done extension of the GOMS model that